In last video, we have seen some true or false that you have to solve by your own self. Okay. Now just tell me your whether your answers are correct or not. Okay. So every natural number is a whole number. Okay. Every natural number is a whole number. Remember the diagram. Okay. Whole numbers include 0, 1, 2, 3, 4 and so on. And natural number starts from 1, 2, 3, 4. Okay. So the answer is true. Okay. Every integer is a whole number. Every integer is a whole number. Whole number starts from 0, 1, 2, 3, 4 and so on. And integers includes negative, zeros and positives. Okay. So negative numbers were not included in a whole number. So the statement is false. Okay. Every whole number is a rational number. Every whole number. Look at the statement. Okay. Every whole number is a rational numbers. Okay. Whole number starts from 0, 1, 2, 3 and goes on. And rational numbers, it means we have to write in p by q forms, and q cannot equals to 0. P and q are my integers, and integers also include the whole numbers. Okay, so we can say that every whole numbers is a rational number. So this statement is true. Every rational number is an integer. Now, every rational number is an integers. Now, look at over here. Rational numbers, the numbers which are in ratio forms. Okay. And the integers, it means all the negative, 0 and positive numbers only. The ratio forms numbers were not included in integers. Okay. So every rational number is not integer. So the statement is false. Okay. Now, every rational number is a real number. Every rational numbers is a real number. Remember the definition of real number? Collection of all the rationals and irrational numbers, we call it a real numbers. It means all my rational numbers comes in the real numbers. So the statement is true. Okay. Now every real number is rational numbers. Now if this statement is true, then this statement is false only, because every real number is not a rational numbers, because in real number we talk about irrational numbers also. Irrational numbers will not include in a rational numbers. The statement is false. Okay. Every point on a number line is of the form root m, where n is my natural number. Okay. Every point on a number line is of the form root m. Okay. Where m is my natural number. The statement is false. Now, look at this question. If a divided b is a positive rational number and a is my positive integer, then b can be any one of these following. Okay. So look over here that a divided b. This ratio is my positive ratio, where a is positive. Okay. So what are the possibilities? We know that positive multiply with positive, we get positive. Negative multiply with negative, we get positive. Positive multiply with negative, we get negative. Negative multiply with positive, we get negative. Okay, we want this ratio should be positive. So this two possibilities can happen. Okay, so if A is positive, then B could not be negative. If it's negative, we get the negative over here. Okay, so my ratio became negative. So what is the possibilities? The first one, the B should be positive integer. Okay, so the answer is B is positive integer. Now look at over here. The option says non-negative integer and non-positive integer. Non-negative, it means positive integers only? No. Non-negative, it means we have to exclude all the positive numbers. Okay, it means it remains with the 0 and 0, 1, 2, 3, 4, all the numbers, and non-positive integers. Non-positive integers, it means negative integers we have to exclude. The remaining ones is 0, 1, 2, 3 and so on. Okay, the 0 will include over here. Okay, if Q became 0, it not possible because of the ratio definition says B is not equals to 0. That's why these two options will not come. The answer is positive integers. Okay, the rational number between 3 and 4 is, we have to find which rational numbers lies between 3 and 4 among these 4 options. Okay, now let's check out. Okay, 21 divided with 10. Okay, now using the method we 3 multiplied with, we have to make the denominator same. It means we have to multiply and divide with the same number. So 10 and 10, which is 30 and 10. Okay, now the fourth one is 4 and 10 and 10. So we get 40 and 10. Okay, so 3 and 4. It means 30 upon 10 or 40 upon 10. Now look at over here. 21. 21 and 30. 21. 3 equals to 30 upon 10. Okay, so 30 upon 10, 31 upon 10, so on. 40 upon 10, which is equals to 4. Here 21 is less than this 31. Okay, is less than this 30. Okay, so the 21 upon 10 will not comes between 3 and 4. So this option is false. Now option B. Option B says 47 upon 100. Now use a smarter way. Okay, instead of multiplying with 100 and 100, simply just look at over here. We just convert into a decimal point. Here we get 0.47. 0.47. Obviously 0.47 is less than this 3 by 4. Obviously, na? Less than 3 by 4. So this also, this one is less than 3. So again this numbers is not lie between 3 and 4. Okay, or else you can similarly use this method also. Okay, you have to multiply this 100 with 3 and 4 likewise. Okay. the option C, 16 upon 5. What am I doing is, I am making the denominator same. Okay, so I am multiplying 3 with the 5 and 5. So 15 upon 5. Okay, now the fourth one, multiply with the 5 and 5. 20 upon 5. Now look at over here. 16 upon 5. Here the 3 is nothing but 15 by 5. The next one is 16 upon 5, 17 upon 5, and so on. 20 upon 5, which is my 4. As you can see, 16 upon 5 lies between 3 and 4. The option C is the correct one. Now, let's check the D also. The D says 46 divided with 8. Again, using the same method, we making the denominator same. So, here the 3 multiplied with 8. 8. Then 24 divided with 8. The next one is 4 multiplied with 8 and 8, which is 32 and 8. As you can see that 46 is greater than 32. So this option D is also incorrect. Okay, because we know 3, 24 upon 8, 25 upon 8, and so on. 32 upon 8 equals to 4. Here is 48 upon 8. This reason is enough. Okay, note it down. Now, we are going to study rational numbers and irrational number in a different point of view. We are just looking for their decimal expansions. Okay, so my real number the first one is say terminating and non-terminating. Let's just take one example. Say 7 by 8. Now we simply just do the division. So 8 divisible with 7. Here. We know that it cannot divide 7. So we just put point. 6. Again it's not divisible. Again it's not divisible. Now, here you can see we get remainder 0 over here, and now we don't have to do further calculations. Now, as you can see 0.875. Now the portions stop over here, so we call this one is a terminating. Okay. Now, the terminating it means after certain step of divisions, it stops, it terminates, it ends. Now, we talk about a non-terminating. Okay, so similarly like this one, which is not terminate, which is not end after some steps of divisions. Okay, let's say one example. Say 3 upon 10 upon 3, 10 upon 3, are 9. Again remainder 1. It's not divisible. You put point. Okay. 3 3s are again 9. Again remainder 1. If we put again 3, 9, 1, 3, 9, 1. Okay. It goes like this way only because continuous. See, it's repeat. It's remainder 1, 1, 1, 1. Okay. It's go on and on. So we can see that its portions is never stop, never ends. So we call this one is a non-terminating. So we just write the definitions. Okay. Sum now we just write the definition. Sum decimal expansion end or else terminate after some finite steps of division. We call this one is a terminating. Now not terminating, it means the decimal expansion in which remainder never zero is called non-terminating. Okay, after certain steps, as you can see, the remainders over here, when you do the first step, it left with the remainder 1. Now, the second step, again left with remainder 1. So, its remainder never 0. We call it a non-terminating. Over here, we get after some stage, we get a remainder 0 over here. So, we call this one as a terminating. Okay. Now, from this terminating and non-terminating, which one is the rational number and which one is the irrational number? Okay. So, real number. Collection of all the rational numbers and irrational numbers. numbers? Now, rational numbers, it means we can write those numbers in P by Q form, where my P and Q are integers and Q is not equals to 0. We know that is definition. Okay. So, we have take one example, 7 by 8. Okay. So, we have seen this example. Okay, so this one is by terminating. It means we can write this number in a P by Q form. Okay, and here, look at over here, 7 and 8. 7 is also my integer and 8 is also my integer. Now let's just read. 8 by 7, 0. 0, 64, 6, 0, 0, 0. Okay, so we get the remainder was 0. The answer is this one. So, this one is my terminating. So, you can write this things in a P by Q form. So, such type. So, this one is the example of terminating. So, we can say that all the terminating numbers we can write in a P by Q form. So that this terminating is goes with the rational numbers. So, the first one is terminating. Okay. Now, the second one we have seen is non-terminating. Okay, non-terminating. We have seen one example, 3 divided by 10. Okay, so 3 3s are 9, 1, 0, 3, 3 3s are 9, 1, 3, 0, 9, and 1, and so on. Okay, so we have seen that it's keep repeating its quotient. Okay, so it's keep repeating its quotient and remainder never becomes 0. So this one is the example of non-terminating. Okay, so here this quotient we can write 3.3. Now as you can see that 3 is keep on repeating. Keep on repeating. No other elements are given over here. Only 3 and 3 is keep on repeating. So we can write this 3 with bar. This symbol it means this number is keep on repeating. Okay. So we can terminate this way. That's why this non-terminating and repeating. Okay, non-terminating and repeating are goes under a rational number. We can write this one with. We can write this number in P by Q form because here after you write in the decimal form, we can see that its quotient is keep on repeating, and repeating element we can terminate like this way. So we can say this is goes under a rational numbers. Okay, so here non-terminating P by Q form where P and Q both are. Look at over here. This if P and Q here. P is 10. 10 is my integer. Q 3 is my integer. P is 7 is my integer. Q is 8. It's again a integer. And look at over here. Q is not equals to 0. Okay, understood? Now note it down. Now, let's take one example. Say 22 by 7. 22 by 7. Now just divide this number. Done? Okay. Now try to solve this one and find out what quotient will you get. Okay? And 10. Okay. So you have seen that when you divide this one, so okay, as you can see that when you solve this one, observe the remainder. Okay, as you can observe, a non-terminating but repeating, your remainder is also keep on repeating. Okay, so and look at over here, it's remainder. When you divide, when you do the first step, you get the remainder over here 1. After 3, 2 and 6, its remainder also keep on changing. Okay, now look at the quotient. Quotient is 3.142 and so on. It's not repeating. So this kind of numbers we put in a irrational numbers. We cannot write this number in a P by Q forms. So here my category of irrational number is not, it's not terminating and also it's not repeating. Not terminating, netting and not repeating. Okay? Done? Now note it down. Okay. Now we understand what is a terminating and non-terminating. Now just keep on mind these important points. The first one says a remainder either became zero after certain step of division or it's keep on repeating themselves. Okay, we have seen two examples like that one. That's 7 divided with 8. We have seen that after certain step of divisions, we get the remainder 0 over here and 10 upon 3 we get the remainder 1 which is keep on repeating themselves. Okay. Now the second thing we have observed that the number of entries in a repeating string of remainders is less than the divisor. Okay. Now the third thing we have observed that if the remainder repeat them, we get a repeat block of quotient. Okay, we know that 10 divided 3, we get 3.33333. Okay, so whenever the remainder repeats, we get the quotient also in a repeat digit. Okay, now non-terminating, non-repeating type of represent is for irrational numbers. Okay. Now, what do you talk these things?